things going here. All right. And there we go. Okay. So yeah, yesterday we talked about standard solutions, and again, I told you before here, we're not going to talk about dilution or stock solutions. That's in the next lesson. We're going to do that right away here. But we talked a little bit about standard solutions, and remember, just by definition, a standard solution is any solution whose concentration is accurately known. Why is it accurately known? Well, because we either made it or somebody made it, but we know exactly how much solute, or in some cases how much, yeah, solute, I guess, is in how much solvent. Usually, obviously, water, but could be something else. Okay. I asked you to do this example for me yesterday here, and let's just go through this real quick here. So it says what mass. So we're looking for the mass. We have a volume here, it's 100 milliliters, and we have a concentration here. So I want to figure out what mass of sodium chlorate do I need to use to prepare this solution. Okay, well, again, I have C, I have V, I can find N from that. So I'd use this formula here, C equals N over V. And very, very often here, we're going to be doing a little bit of this N equals C times V thing here. Okay, so if I put that in, let's see, C is what, 0.15 molar. And V is 0.1 liters. You got to make sure you're using liters in this formula. Make sure, and that'll give you 0.015 moles. Okay. Now, I know that, and I happen to know we're looking specifically for sodium chlorate. So again, find the molar mass of that, and we're going to use this formula now to find the mass, because this is the formula that, you know, anytime you're asked to solve for mass, this is the formula that does that, right? So we're going to do a little M equals N times big M, and my 0.015 moles would go here. And my molar mass, which I did yesterday, was 106.44. That's for this right here. 106.44 grams per mole. Okay. 106.44 is what that says there. I know it's super messy. I apologize. 106.44. Okay. If I multiply those two together, I will get 1.6 grams of sodium chlorate is what I need to use. Is that good? Any questions, anyone? Yes, no? Okay. And that's how I would calculate the mass that I need to use. So basically, if I wanted to make this solution, I would take 1.6 grams, I would put it into 100 milliliters, and I would get this concentration. That's basically what we're doing here, okay? And again, we have to figure that mass out that we need there. How much mass do we need, okay? Is that good? Any questions, anyone? Okay. All right. Now, how do we do this? Well, again, we're going to go to the lab, and we'll do this, but we're going to use an electronic balance or a scale of some sort, because we have to weigh out that 1.6 grams. And to prepare a to prepare a standard solution, we use something called a volumetric flask. Okay, and usually we use 100 milliliters. Okay. So if the question doesn't say, we assume 100. This is important. If you don't seem like you have enough information, we're going to assume we're going to use a 100 milliliter volumetric flask. Okay. Now, the reason we use something called a volumetric flask is because if you think about what's going to be accurate, what is something that, how would I measure out 100 milliliters accurately? And the answer is, well, if you used a beaker, you don't have to write this down, but if you use a beaker, it kind of looks like this, yes, roughly. And I know my drawing skills are just wonderful, but just go with me here. And of course, it would have, you know, these little divisions on here. You guys remember the beakers in the classroom there. But that's not very accurate, because if you think about some water in here, my water is purple, by the way, but if you think about some water in here, okay, like this, that's pretty tough to get an accurate reading. Because if this was, let's say it was a 100 milliliter beaker, this would be like what, 20, maybe 40, 60, 80, and 100, let's say. And it'd be pretty hard to get an accurate reading of that. Okay, whereas exactly 100, for example, you know, we say it's this line, but you know, it could be a little bit below, it could be a little bit above. It'd be really hard to tell. So we use something called a volumetric flask. And if you bear with me for 1 second, this is what a volumetric flask would look like. Okay, hopefully you guys can see that okay-ish. Yes, no? Yeah, okay. Now, things that you're not going to see here, and I don't know if this is going to work or not, but no, it's not. Oh, it's even better now. You can't see this, but this top part, see the top, the very top there? It looks like a little dial up there. That is just a stopper. That's not anything special. That's just basically to plug it, okay? It's like a stopper. That's all it is, okay? And I'll show you these tomorrow when I get back. This one happens to be a 250, and I know that because if you look really closely at the bottom, it says there's an A there. It says 20 degrees Celsius, and if you see right beside that, it says 250. I don't know if you can see that. I don't know how clear it is to you, but that's what it is. It's 250, okay? They come in different sizes. This flask is called the volumetric flask. It only does one thing. That is it. It's only good at measuring, in this particular example, 250. All right? It only measures 250 milliliters of solution. So what I would do is I would dump the solid into this, and I'll show you how to do that properly tomorrow because there is a little bit of steps with that. But I would dump the solid, let's say it's whatever, 4 grams, and I would fill it up to a line on this volumetric flask. This is going to be really even tougher to see. What I'll do is I'll draw another diagram here, but I don't know if you can see this or not, but if you look in the neck part, the skinny part, okay, about halfway on the skinny part, okay, I don't know, about halfway, maybe just a little bit higher than halfway, there's a little line there. Can you see that or no? Yeah? Okay, kind. It's very faint. But there is a line there, okay? That line tells you it's 250 milliliters, okay? This is the only line on here. This is the only job of this flask that doesn't do you. If you want to do 100 or 125, this is useless. This is not an option. It only measures 250. That is it, okay? I'll show you another example here, hopefully. Let's see. How do I do that? Yeah, there we go. Here's some more. Oh, actually, here, this is even better. Do you see the lines on there now? Now you can see the lines, eh? And again, don't worry about the top part. That's just a stopper that's plugging that, basically. But here you can see some different sizes, okay? Typically, we use a hundy, okay, which is the one right kind of in the middle there. But you can see it's kind of got that brownish line to it. If you move one over, there's a blue one there. I don't know what size that is. I can't quite tell. I would assume that that's probably the 250 one, but I'm not sure. But it's got a blue line there, okay? Those lines are what we call the calibration line, okay? And that's all that that is good for. Like I said, that 100 only does 100. If you look to the right of those hundreds, there's a smaller one. I'm going to assume that that's maybe the 50 one. It only does 50, okay? That is it. That's why they call volumetric. They have a specific volume to them, okay, if that makes sense. Is that good? That's what they look like, and that's what we're going to be using, okay? I'm going to go back to my notes here. So again, that's kind of what we're looking at there, okay? That's a volumetric flask, but we have to use those. We have to assume, if there's no volume given to us, that we're using 100, okay? We're actually going to go right to this example. We're going to skip that other one. We're going to go right to here, okay? So this one now says describe. Now, if we have to describe, we're going to have to write down 4 additional steps, but they want you to describe how you would prepare this 0.18 molar solution of lithium nitrate, okay? Obviously, I have a C here, okay? And again, I have some lithium nitrate, so I'm going to write that down, lithium nitrate. Lithium's a 1+, nitrate's a 1-, okay? And I have to describe how to do this. But first, I need to figure this out. In other words, it's not enough just to describe. I'm going to actually have to do the calculations. So in other words, how would I make this? Well, first thing I say is C. So I'm going to use C equals N over V. And I'm probably going to use a little N equals little m over big M. Okay, like so. So that's the first thing I need to do. Okay, C is 0.18 molar. Okay, so I know that. The V, I don't know, but I know the V because again, in this question, it doesn't say how much they want me to prepare, but I do know this, I have to assume 100, okay? Again, you might say, well, why is it 100? Because it's just right, okay? I tried to make a joke yesterday, but it doesn't really work. I'll do it again tomorrow, where I talk about Little Red Riding Hood in Little Baby Bear's pig's bed, okay? Um, it's just right. It's the right size, okay? It's not too much. It's not too little. It's perfect size. 1 liter turns out to be, I'll show you the 1 liter one tomorrow. It's quite a big flask, okay? It's a lot of solution. So we're going to start with this, and we're going to assume, let's make sure we write this down, 100 milliliters or 0.1 liters, we have to assume. And that's going to give me 0.018 moles. Okay, 0.018 moles. I'm going to use that with the molar mass. And I'm going to find out the mass that I need to use basically to make this concentration. So molar mass, let's see, lithium. Oh, I don't do enough lithium apparently. What is it? 6.94. 1 nitrogen, so 14.01. And 48, I guess, 68.95. We'll just wait here. So again, this will get us to 1.2 grams. Sorry, this right here is 68.95 molar mass, 68.95 grams per mole. Okay, 68.95 grams per mole. Okay, and that gives me 1.2 grams. Okay, kind of exactly the same thing that we did in our earlier example. Yes, no different, except they told us we wanted to make 100. We just assumed it was 100. Okay, now it says describe. So when it says describe, we're going to write out 4 steps. Okay, step 1. Maybe I can do this in, I don't know, maybe can I? No, I can't. Never mind. That was a bad decision. Ignore that. Okay. Step 1. No. Let's try that. Okay. No, for crying out loud. I'll figure out how this works eventually here. Don't worry. It's only my 6th day or 7th day. There we go. Okay. Come on. No, for crying out loud. Okay, here we go. Okay, here we go. Step 1. So we need to basically weigh out. So we're going to describe how to do this. So how are we going to do this? Well, we're going to weigh out 1.2 grams of lithium nitrate. Okay, so you should probably put the weight and the compound that you're trying to use. Okay, in this case, lithium nitrate. Okay. 2. This is what we're going to do for quizzes and tests. Okay, this is what we're going to be writing out for quizzes and tests, basically, are the 4 steps. When it says describe, we're going to talk about 4 steps. We're going to dissolve the lithium nitrate into 100 milliliter volumetric, oh boy, no, we're going to try that over here, volumetric, oh boy, I need a new pen, volumetric flask. Okay, so we're going to dissolve the lithium nitrate into a 100 milliliter volumetric flask. We are going to, and again, we're going to do this tomorrow, fill with distilled water. Distilled water just basically means it doesn't have any ions or atoms or any other minerals in there, kind of, hopefully anyway. Fill with distilled water to the calibration line. Calibration line, okay? That's the little line in the neck part there. Fill with distilled water to the calibration line. And 4, we need to make sure it's mixed up well, mix well. Okay, so we need to basically make sure we shake it up and try and dissolve as much as we need to. Okay, now some compounds will dissolve very quickly, some will take some time. So sometimes when I go to make solutions for you while we're doing labs and things like that, I have to sometimes do those the night before and let them sit so that they can basically dissolve a little bit better than just doing it right before class kind of thing. Okay, so again, those are the 4 steps we're going to use. We're going to do kind of the same thing coming up here in the next part, but this is kind of what we're looking at. Weigh out 1.2 grams of lithium nitrate. We're going to dissolve that lithium nitrate into a 100 milliliter volumetric flask. Again, if we had to make 250 milliliters of solution, we would change that to 250. But again, we're assuming it's 100. Fill with distilled water to the calibration line, and we're going to mix it well. Okay, and that's how we make a standard solution. And again, there's a little bit more to it. We'll talk about that tomorrow when I get back. Okay, good. Yeah, huh? Yeah, ask. Yeah. Mm-hmm. Yeah, so we'll do this tomorrow. I'll give you a demonstration tomorrow, and that's probably going to be tomorrow's class, I think, because it's going to take a while. But um, tomorrow I'm going to show you how to do this so that when you guys go to the lab, you guys can do this on your own kind of thing. But you first of all want to dissolve it, and the reason is because we're going to start with some solid, and in order to make sure that solid gets into that flask, I'm going to show you one of the issues that it's not an issue, it's something that we have to be aware of. Those neck openings that you have to put that into they're pretty tiny. So we'll have to use a funnel. We'll have to make sure we get all the solid into that flask. So to do that, we usually try to dissolve some of it and make it a solution while it's going into the flask. And then we'll fill up the rest with some distilled water. And again, I'll show you that tomorrow. So if you're not quite sure what I'm saying there, we'll address that tomorrow if that's okay. Okay, that's kind of what we're looking at. Okay, all right. So that's all I got for that lesson 4 there, and that's how you make a standard solution. Okay, usually we're going to have a concentration. We'll have to, in most cases, not all, but most cases, we'll assume it's 100 milliliters. So that gives me C and V. We find N. Okay. Once we know N, we know the molar mass from the compound. We find the mass. That's how much solid we want to use. Okay. And that's where we start. So we weigh that out. We put it into the volumetric flask. We fill it to the calibration line. We put that little stopper in the top part, and we basically shake it up. Okay. And make sure we dissolve that. Okay. Is that good? Any questions, anyone? Okay. Well, let's move on to lesson 5. Now, lesson 5, Mrs. Fletcher is going to hand that out, so we'll take a quick little break here. And anyway,